Hey TechKnowStuds, your devices are going to do some sort of queuing. That is, they're going to queue up packets before it sends it across whatever connection, whatever port that it's going to be leaving. But there are different queuing algorithms that you can use. So let's get into queuing algorithms and what some of those algorithms look like. In this video, we'll start out by talking about what queuing is. Then we'll get into the different types of queuing, and then we'll talk more in depth into what is first in, first out queuing. We'll talk about weighted fair queuing, class-based weighted fair queuing, and finally, low latency queuing. And so those are the different ones that we're going to take a deep dive into and see what the differences are between these different algorithms. In an ideal world, we wouldn't have much queuing going on our network. But the problem is we have a lot of devices on our network that's communicating, and there are times when links can get saturated. So for instance, in this, if all of these devices are going into different ports on this switch, but then it's got to go over a single port to this router right here, we may have to queue up all of these packets to be sent to this router. So that's where queuing takes place. Queuing is like a buffer where we stack things into it to be sent back out on the other side. And so we have to have some sort of memory that does this. And this is one of the differences between a cheap switch and a more expensive switch, is a cheap switch has a lot less buffer, has a lot less memory, and can queue a lot less, where a more expensive switch has more capabilities of doing this. So one way that we can implement queuing is just first in, first out. So that just means that whatever is coming into this device right here is going to send out on the other side. Now, the problem is as congestion comes up, then these other packets are waiting, these frames are waiting to be sent out. And we can see that there's voice that's in here. And so the problem is that now there's a delay to when these voice packets can get sent out to the other way. Could cause some problems with quality of those voice connections. Then we have weighted fair queuing. WFQ, or weighted fair queuing, is an attempt to make things a little more balanced within our network. So we have our different queues. So these different types of traffic go into different queues, and then they are sent out the other direction. And these could be a certain amount of bits that go through before it toggles to the next one, and then to the next one, to the next one. Or it could be the number of packets that go through there. So somehow it times the amount that is given to each one of these queues in here, and it gives equal time. That's the importance, the key aspect of this is it gives equal time, whether it is in the number of bits or the number of packets that go through here, but it gives equal time to each one of these queues. Then we have class-based weighted fair queuing. Class-based weighted fair queuing is very similar to weighted fair queuing. And so we have different classes that we've identified this different traffic. Now the differences with this class-based weighted fair queuing is we can actually set up different bandwidth or different levels that each one of these is going to operate at. So we are giving more bandwidth to this voice data right here. The idea behind it is more bandwidth means that there probably is going to be less delays for this voice data. And then we've given a little bit less for this type of data, and a little bit less for this type of data. And this last one we've just said is best effort. It's going to be the first one to get dropped if there's any contention in the system. Now, one nice thing about this class-based weighted fair queuing is we can give it some sort of guarantee of bandwidth. And so this is the guaranteed bandwidth right here, and we can also set a limit. So for each one of these queues, we can really get more granular in how much traffic we allow across there. And in a sense, we affect to a certain degree the preference of this traffic. So in this case right here, we may devote quite a bit of traffic available for this voice, maybe not quite as much for this type of data, maybe a lot for this type of data. We're able to really hone that in on what amount of bandwidth is going to be given for each one of these queues. Now, one thing to note about this is that this is still not prioritized right here. This voice traffic is given more bandwidth. The idea is that it'll have more opportunities to send out the other side, but it doesn't necessarily guarantee that there's going to be a priority that's going to be put on that. That's where low latency queuing comes into effect. It still implements a class-based weighted fair queuing with different classes, but we also have this priority queue that will bypass everything else and put it out in front. And so that is the low latency queuing, which allows us to quickly get the traffic that needs to be prioritized on its way. So getting back to our model here, we have queuing here sitting towards the end here that's going to queue things as it's ready to go out the egress ports here. And so things will get queued up. But we can actually classify the data. So we classify the data back here to use with some of our queuing algorithms if we've specified one of those queuing algorithms. So there you have it. That is queuing. We talked about the different queuing methods. We talked about first in, first out, which is just a method of whatever comes in first is going to be the first item out, and things just get stacked up. We talked about the weighted fair queuing, which allows us to have different classes and identify traffic and categorize traffic, and then give equal opportunity for each one of those types of traffic. We got the class-based weighted fair queuing, which we can actually identify bandwidths and restrictions for each one of those queues that we have. It gives us a little more granular control over how much bandwidth we devote to each one of those classes. And then we've finished things off with talking about the low latency queuing, which identifies also any priority packets that needs to be prioritized over all other packets. So that is some of the different queuing algorithms that we can use and implement on our network.